Hello, hello. How are you all today? Hopefully you're doing great. On this side is super sunny. I have enough of coffee, so I think we are ready to start. In today's stream, I'll try to analyze software dependencies in Python, C++, and Rust. Basically, we're gonna visualize some stuff and also maybe run some stuff, some algorithms if we get there. And yeah, if you like this content, please like, share, subscribe for the future. And yeah, let's get started. Yeah, if you have any questions or any comments, please put them in the chat. Okay, let's get started. So, in order to analyze dependencies, we need some project to analyze. I think the perfect example is the Memgraph repository called the Mage, because it has all these three languages in there, and in the future it's gonna have probably a lot of dependencies. So this type of analysis will be meaningful. So Mage, let's get into Mage. All right, we are in the project, so let me just check out the latest version of Mage. Yeah, I haven't pulled stuff for a while here, so git log, yeah, that's Rust query modules, but immediately some issues, but main, yeah, untracked files, git cleanup. Let me just check what is. Let me just check what is latest there, just to know some stuff on the algorithms. I think we can actually delete all this. Well, what is the latest here? Yeah, this is something super old. I'm not sure why is that conflicting now, but yeah. I think we can even delete all this. Yeah. Git pull. All right. Now we have a clean repo here, which is good. Okay, so yeah, let's start from this point, from the last commit we have here, and yeah, let's go alphabetically. So C++ first. So in C++ code, we have a CMake. So CMake is a build system used in I think majority of C++ projects, and we're gonna use that tool to generate these dependencies. So let me quickly Google that CMake. CMake dependency graph, we have that option here to generate a graph with visualization out of a CMake dependencies. So a graph is a tool to visualize static graphs. You have that dot language, which is very convenient to, which is like a text file. I mean, the language as is have these arrows, and you describe graphs, but you have a file, and then you write these language syntax in there, and you recreate graphs. This is this, for example, here is a triangle. So yeah, fairly simple. It's fairly simple to create graphs. What is tricky, it's to get these dependencies out of a build system, but that's also not tricky. It's system usually have something to generate these things. So as it says here, we just need to add this argument here. And yeah, in the CMake environment, since we actually have to build the project, I think creating a build directory and then just running CMake should be enough. I'm not sure if I can generate these things immediately here, or I have to build the entire thing. So CMake graph is food dot. We actually have something. So the tool generated, maybe I can make this a bit bigger. So the tool generated a bunch of files, and let's open that. So if we go under Cpp, build, and then we have foo dot, here we have all these nodes listed and connections between them. So yeah, we have a node name and then a label attached to it and shape. I'm not sure what's the shape, what shape represents, but we're gonna figure that out. And then we have connections between node 65 and node 20. These are some IDs of these nodes in the graph. If we open these, this is just a subgraph for a specific component. We'll just visualize this main one, and that's it. In order to do so, we have to generate an image or PDF out of the dot file, and that's done with a GraphViz tool. That's installed if you type sudo apt install GraphViz. That's for Ubuntu. I already have the GraphViz, and yeah, if I execute this, that's gonna create a PNG file here, and we can open it through PNG. Boom. Here we have a graph. Let's zoom in a bit to do that. So we have, for example, bridges, cycles, PageRank. All these modules depend on MG procedure, which is a C API to interact with the graph inside Memgraph, and MG utility. This is a package to a module or package to make the coding easier. But yeah, all of them are using that thingy. And also there are tests, and test depends on on the gtest. That's the Google testing suite library. Yeah, I think, yeah, I'm not sure what are these shapes, so I assume these are the binaries or something. Maybe here is a explanation for that. This is some other example. It doesn't say much because I don't know what is what. Aha. Here it is, executable house, static library. So if this is correct, so executable is a house. Yes, this is a house shape. Static library is a diamond. We don't have that. Think so. All these are dynamic libraries. Shared libraries is polygon and octagon module library. Yeah, and what is the... We also have a circle gtest. What is that? Yeah, I'm not sure. Taken from CMake source. Yeah, okay. But anyway. But yeah, actually that might be useful later on. So I'm gonna copy this and put it. So let's make a script out of this. Let's call this folder depths for now. And then if we go back, mage, run sh. Let's make a bash script out of this. All right. Let we have some example. No, that's all Python. We use Python here for building stuff. Yeah. Yeah, let's do Python. Let's not do get working directory, work directory, la la la. No. Let's delete all this for now. Okay, how is that done here? We have work directory and then we navigate through that. We're gonna take this. Okay, since we don't need this for now, let's do this for now, and then OS CPP directory. Okay, we are now in the CPP, but we have to be under build. Yeah, let's just make this little hack for now. Run, we have to run CMake. Oh, we have to run this thing here. CMake equals foo dot and then dot and then we have to run this not sure why I'm getting that much output in the let's add these things here. All right. Depths chmod plus x analyze boom. Depth cpp build. We have to go one folder above. Boom, we have that. Okay, and then we have to now we have that visualized, but yeah, we also need a CMake here. Does it work if I delete the entire folder? Yep, it's gonna run everything, which is great. And here now we have again everything. Oh, foo.png. Boom. Nope, actually nope. What's the problem? I know. No. Do we have? Yep, but it seems that graphics doesn't work or something is broken. No, maybe since I deleted the last image, maybe something was missed or something. But okay, okay, that's more or less it. Okay. Nice. So that's more or less it about C++. So in the bigger project, we'll be able to see what much better see what is going on. So let's try another one. The next one is Python. So in Python, there is another library, Python pip. Python dependency graph. What do they say here? Pip tree is interesting. Does it have some kind of graph with output? No. Oh, it has graph output. Okay. Okay. In the Python case, I think I need Python directory, Python. All right, and Python here. Py directory. We end up in there, and activate. We need pip tree. What's gonna happen if I just run this simple foo dot? Yeah, in bash that would be much better. I have to add these things, but we won't have much of these, so should be fine. All right, what's gonna happen if I run this? Yeah, pip tree does not exist. That's actually interesting because I have to install somehow pip tree. Open and then Python. Python from that virtual environment and then opens a script. But this is not a script. This is a standalone binary. That might be a problem. I mean, I can activate an environment here and then just run this script. Yeah, let's do that. So instead of figuring out stuff here, I'll start a virtual environment here. AV3, yeah, we have that. Pip install pip dep tree, which is nice. And if I run analyze now, unrecognized arguments, foo dot. Python. Dep tree. Obviously, this is this outputting stuff on the SD output. JSON graph output print a dependency in a specific output format. That's the format. JSON package reverse. Yeah. That's why. Yeah. Sub process. Pipe sub out to a file. Yes. The out file. All right. Yeah. With open. So this is now a bit Python specific, but fine. So with open, we're gonna do foo dot for writing as file, and then std out equals file. What's the problem now? That should be fine, and we don't need this anymore. Std out. That's subpro. Subprocess run. But a run also has. Okay. If we run analyze again. So GraphViz is not installed but necessary for output, but I have GraphViz installed. That's probably because Python package is not installed or something. Python GraphViz. Yeah, I think that's the one we need. Okay. Free. So this command will give all the dependencies. So pip3 2.0. Yeah, okay. And we also have. So we also need GraphViz pip install graph. We're gonna just install the latest one, which is 0.17. If we run pip freeze again, we got these two. Okay, let's analyze again. Boom, nice. So this time it works. ls Python foo. Boom, amazing. Python foo dot Python foo dot. Here we are. We have this. But we analyzed the wrong, environment. We actually analyzed the current environment. Yeah, that's not great. All right. Not gonna fly. The requirement file, the requirements are fine, but yeah, pip freeze. So we're gonna txt. We'll have the requirements here, but deactivate. We need to deactivate that. We have to delete this virtual environment, and we have to go back to Python. Here we have the requirements file. Do we have? How is this actually? So we just rely on that. Yeah, I'll just create a virtual environment in the Python repository, in the Python directory. I have these aliases, so SV3 is start virtual environment and AV3 is activate virtual environment. So pip install -r requirements. Okay, now I'm gonna install all the requirements. All right, and also I have to go under Python and activate pip install. No. Deps. Okay. And now I think I can run analyze. Oh, great. Now we have all of the requirements from the requirements file in the Python folder, which is great. But let's just refactor a bit the code. So because now I created these files, foo dot python foo dot. I don't need this, and instead of cp deps, cpp deps, and then also I actually do not have to position under Python directory. I'm okay to be under this directory. I just need the virtual environment activated. -o. Work directory / cpp dots. Okay, and yeah, I need the same here. So f work directory, cpp dots, and also here. I don't know why is that opening. Nice. And let's call also formatting. Now we have inside this repository png and cpp dots. Nice. And also here, but I also need to run sub process. Okay, I'll just copy paste this for now to not so by deps and by deps. If I run this now, it created all sort of things. Cpp deps, cpp png, yeah, that's the same file, and by deps png. Boom. Nice. So we have an actual, a more interesting tree. So the Gecko library depends on NumPy library and also Flask course and Flask and Jinja, and then all Flask dependencies are listed here. If you are coming from Python ecosystem, you probably know Flask and its dependencies like Jinja and Werkzeug. Werkzeug, or how is that pronounced? I'm not 100% sure. All right. Amazing. Let's just to be complete. Okay. How to list all files? Yeah, not sure. Short branch status long. What's that long? Nothing. Verbose, untracked files mode. Untracked files equals all. Yeah, that. Okay, we have all these files. Let's put some of them in the git ignore. Star dot star. We don't need dot files and we don't need png files. Boom, amazing. Okay, but we also kind of want to move all of them somewhere. But yeah, I will do that later on. Okay, that was Python, and now let's do Rust. We don't need that. That was kinda unnecessary. Pip3. So we use this. We use pip3, and we use also Rust. No, we actually cargo dependency tree. Specifying dependencies. No, that's no. Cargo tree. Yeah, cargo tree is nice, but not useful. Does it have some kind of... I don't see any graphics output. Cargo depths. Here we are. Cargo subcommand for building dependency graphs. The project is of old and maintained cargo graph. Nice. Cargo install cargo depths. Okay. So, that's gonna be a bit tricky because we have isolated projects, but for the purposes of this example, we're gonna just analyze the example thingy. Can I run cargo install cargo depths? Okay, that's a globally installed package. Yeah, I'm gonna just make a to-do here. Install, ensure cargo depths. All right. Cargo depths. If I run here, okay, rsmgp example, cargo depths. Wow. Okay. Nice. That's also set to the std output work directory, so we can be we'll end up there, and then yeah, okay, rs directory Rust. We'll move into the Rust directory. rs directory. Bum bum bum. Bum bum bum. And we have to actually open file for writing again. So rs directory rs deps dot bum bum bum, and we need to run subprocess run cargo no Rust, and here we're gonna end up rsmgp example. We're gonna go there, and there we're gonna run cargo deps and output to that file. And once that's done, 5yy we jank that work directory, yes, rs, and I think we're gonna have that visualized. So ensure that, and also to do, we have to analyze all Rust modules. Mage. Great. Okay. Deps. Analyze. We don't have rs deps dot because it's not there, it's here. No. Work directory. Of course, I put it in the wrong directory. So the just a moment, I haven't explained that. Alias O is just opening xdg open, and that's very useful command because you can open various files with the same alias. Ooh, nice. So we have here a very nice graph. So RSMGP example depends on RSMGP sys and on cstr macro, and then the system library depends on bindgen, which has a bunch of dependencies here, and then RSMGP depends also on snafu, which is the error handling library, and mocal double, that's the testing stuff. And this is a really nice graph, and yeah, amazing. So okay, Rust RSMGP example, that was a mistake. If we Okay. That's quite nice. Okay, essentially we have all the dependencies from all programming languages we use. Now the question is, what do we do next with that? We can push that into Memgraph and then run some analysis. For example, PageRank or something. But yeah, I think I'm gonna leave that for a later video. I think I'm gonna stop here. And yeah. All right. Yeah, if you have some ideas on how to actually what to actually do with this for a more complex projects, for example in C++ or Rust, build times are depending on these dependencies, and you can optimize build times if you understand dependencies, and that's actually my end goal in general, to do some more advanced analysis on these dependencies, and then figure out what makes sense to be what does it make sense to optimize. But yeah, that will take a bit more time. If you have any ideas on how to like what would be useful in terms of analyzing these dependencies, please let me know, and we can work on that. We can figure something out. Yeah, I think that's it for today. Hopefully this was fun and enjoyable. Next weekend I'm gonna just a quick note. Next week I'm gonna skip because I'll take some time off. But then after that I'll try to be super consistent with Saturday streams. No questions, which is fine. Hopefully this was clear enough. I'll commit that repo as a draft PR into the Mage, and we'll optimize that later on. But yeah, thank you very much for watching. Have a good rest of the weekend, and yeah, take care. Bye bye.